Hello everyone, sorry for the wait. I think we can start. So the topic of this lesson is to talk about test-driven development. Even though the whole chapter is called test-driven development, today's focus will be to talk about how you actually implement the flow itself. Before we start, let me give the announcement in another channel as well. Streams. Okay. The point of this lesson is to talk about test-driven development in practical flow. In previous lessons, we learned why do we need tests, and in this lesson, we'll learn how to actually implement test-first approach. Today, we'll talk about writing test before code, inside out and inside in thinking. Which one should you pick? Or maybe both. How do you lay out requirements in a test? How do you do thorough testing? What flow you should do if following test-driven development before you make a pull request? And what's the benefit of writing test first as opposed to writing test last? First, let's talk about the two choices you have when starting fresh, either creating a feature or a whole project from zero. You can either start from creating highest level components or lowest level components. In any case, if you're starting from zero or from a feature that doesn't exist, you still, if you want to write test first, if you want to follow test first approach, you are going to write test for code that does not yet exist. And in a system level, that's even more of a problem because you're going to integrate code that doesn't exist in a system that sometimes might not exist as well. And these are the problems. Outside in is basically a top-down approach where you look at the system from a perspective of a client or a customer. You understand what it needs to do in a story level, in feature level, but you don't really have an idea how it's going to do that. Therefore, such outside-in design, especially in testing, will follow a lot of mocks and replacements and dummies. Basically, the whole thing can be compared to an egg, like egg and chicken, which one came first problem. And in this one, in outside in design, a chicken came first. Inside out design can be compared to egg coming first, from which a chicken will come. Lowest level components, and in domain driven design, that is models, do not require complex dependencies. In fact, they often don't require any dependencies. And the benefit of having inside out design, starting from lowest level and moving to higher level, is that you do not have to care about dependencies because there aren't any dependencies in the context of what you're working with. And therefore, you can gradually introduce dependencies. And of course, you'll still need to escape the dependencies in higher levels to escape lower levels references. However, when working with lower levels, there won't be anything to escape from. That's why tests will be really natural, because you will test components as is. And here are the benefits, which one you should pick, inside in or outside out. Outside in or inside out. Outside in benefits are that high level details tend to change. And if you're testing high level stuff, well, your tests will also need to change due to the change of high level details. Mocking everything will be your daily routine because there are dependencies that don't exist and you need to swap them with something. It forces us to care about dependencies that don't exist and maybe about implementation details that shouldn't even matter yet. And for those reasons, outside in is simply more complex and is not recommended. Inside out, however, tests the core of a project first. And so testing is easy and it's likely not going to change. And those two are huge benefits that alone should be the factor that determines which one you should do. That said, for other reasons than testability, you should create quick and dirty stub for high-level APIs, and then go back to the core of your domain and design a proper domain where it's fully done, and then slowly swap the inside-out design, swap the dummies with the inside-out design that you did, with the models, components that you did with that design. Now let's try to learn how would you approach a problem given a TDD flow. The essence of TDD is understanding what is the requirement, what is a definition of done. In other words, before writing a test, you need to understand how complete looks like. And this involves relations that the object has, or the system, or in short, a unit on the test has, and how will that unit be consumed by the whole system. What does this mean? Let's take some not trivial, it's actually quite okay-ish problem that I failed to solve in the time for this lesson, so we'll solve it together. Anyways, there's the problem. Balanced strings. I took this from LeetCode. Basically, there are balanced strings, and a balanced string is made of all L and R characters. And a balanced string is a string that has only those characters, and it has always at least one like balanced string. So basically a balanced string is a string that has an even amount of L and R characters. And your goal is to find how many balanced strings there are in a given string. And I didn't quite understand the problem initially, so when I was making examples, I kinda made it wrong. But anyways, we'll try to follow TDD approach and solve this problem together. In any case, the whole problem is to return maximum amount of splitted balanced strings, given that a string has L and R characters and a balanced string is a string with even number of L and R characters. Let's get to it. How do I approach this problem? I write test first, and I try to analyze what is the input, and I wrote here any string. Actually, it's not any string, it's string with only L and R characters. Then we have how does a function skeleton looks like? Basically, it's a function that takes a string and returns an int. And I said skeleton of a unit and not a function because a unit can be the class itself or it can be a function. So it varies, or a component per se. Anyways, last thing, what is the expected behavior? That is the assert. So the expectation is that given a string, returns count of substrings with the same amount of L and R characters. The first thing to do when writing, when doing TDD approach is to write a test. And we write the most simple kind of test. If I pass an empty string, I should get 0 as my count. That is the most simple test. And as you can see here, when I wrote the test, it's red. It doesn't even compile because I don't have code yet. But that is the correct approach. You write a function and you test the function in the minimalistic scenario, even though it has no code yet. Then, so we wrote a test, and now we are testing, we are implementing what is on the test. And the minimalistic approach for implementing that is to simply return 0. That is the minimalistic approach. Our expectation is 0, and we just write the implementation so that the tests pass. We did that. We covered the minimal. Now let's move to the next scenario. Happy path. Simple happy path that would cover a simple rule. If there is L and R a single time, we return 1. Now, if there is a string and actually that A is not valid, so it actually should throw an exception and not 0, but that is my misunderstanding. Anyways, if you pass L and R, it returns 1, and that is our test. Happy path, minimalistic scenario that involves business rules. And this is the implementation, which is actually a bit wrong because I misread the requirements. Find count basically says if string is null or empty, count is 0. Else, we try to make strings of balanced strings, basically. If it's a balanced literal, we append the character to the string that we're checking, and when it's finally done, when all the literals are there, we check if that string is balanced or not, meaning which if it has the same amount of L and R characters. And based on what we have here, it works. But unfortunately, that is not really what we're asked to do. So we need to fix that. When we add more complex cases, and let's say edge cases, well, those are still minimalistic cases. If we add LLR, for example, LLRR, LR, we have different kinds of input now, not just one balanced string that is returned, but 2. And we need to find that. And let's try to cover this together and implement that part together. And I also added different things. But actually, let's do it after the whole thing so that it will be an illustration. And then I'll also try to implement another problem with TDD approach. Anyways, in problems like balanced string, you also often have sample input output, and um, it's quite easy to just take that input output and feed it to your test in your theory with inline data. That's quite easy. And that's how a full, well, that's just one more method, but anyways, that is what another method for TDD would look like. And if we do test first approach, what do we get from it? We get high code coverage because we don't forget writing a test. It's a human mistake to forget things, and by doing them first, we enforce ourselves that we not only implement the important bits, but we also implement the double checks tests. More time to think on design. While you're working on a test, you're basically um, you're basically thinking in advance what needs to be done, thinking how it integrates to the system. You are forced to think about those things. And while writing the requirements, while implementing the test, you have more time than to just right away implement something that you integrate. It gives us time. And lastly, of course, it gives us time to understand the problem better. Maybe by writing tests, you'll figure out that there is an edge case that you didn't cover, that you didn't understand. And that is what you will understand by writing tests, potentially. TDD is a kind of a hack when applied in uh, work conversations because if you are asked to do live coding, all you have to do is to create a new test project and talk with the interviewer as you lay down the requirements in test cases. And that is really cool because even if you don't make everything in time, you basically just do trivial work by laying out test cases and laying out uh, the implementation as you go. So basically, you talk with the interviewer as you extract the requirements, as you formulate different test cases. So it gives you both time to think and time to show that you have a good sense for best practices such as TDD to the interviewer. In a real life scenario where you work on your daily tasks, your daily issues at work, there's a thing called red-green refactoring. And this means that you start by writing a test, then you implement a unit for that test, then you run the test and fix what is broken. Then, after all your test cases are covered, you refactor the source code, run the tests again, and if it's still working, you raise a PR. And when you're creating implementation for a TDD approach, you don't really care about the quality or any of the standards. You just hack together a solution that works, that is covered by tests. Nothing matters there as long as it works. And this is called duct tape programming because you just duct tape solution from whatever you find on Google. You don't really care. Um, so as long as the end result is a clean solution, red-green refactoring is okay. Like duct taping is okay as long as you don't leak duct tapes in the production. And a few thoughts on TDD. TDD is something that an individual can practice, and it doesn't matter on your workplace. If your workplace writes tests, which most of them do, you can write them in the end or in the beginning. TDD as a way of working is up to you as individual. And if you want, you can write test first. And that is the recommended approach. It's definitely not easy to get started because it requires you to invert your brain to think that it started from something that doesn't exist, and you simply go and implement the thing that is yet to exist. The best way to ensure that everything is tested is testing something that is yet to exist. And it's not that difficult because think in black box and you don't need to know all the details. Just understand what the requirements are, what the definition of complete is. Be minimalistic and do just what is asked and no more. That is a TDD approach. Now let's move on to the scenario that we failed to implement. I will try to implement this thing in just solve a problem basically, and this problem is from LeetCode. That's the problem, and I'll try to implement it properly. Here are the tests that I wrote, and I'll try to fix the implementation now. Basically, the problem is that a string contains only those characters, L's and R's. And I need to find all L's and R's, all substrings, all balanced strings, all chunks of L's and R's that are repeated in a string. And I think I know now. It'll be for each var input, var letter in input. Basically, my idea is this. It doesn't really matter how many L's and R's are in a substring, as long as it starts with an L and ends with an R, or starts with an R or ends with an L. That's all that matters, I think. So we'll start with is started, is start of a substring. Basically, it signals if we are not in here. That's what is start of substring signals. And we say that we are there, I mean. This is the start of substring. And at this point, it ends. If maybe we can approach this a bit differently as well, which is by saying the character that we have. So previous character we can say it's this. And we can simply say if letter is previous character, if it's a different letter than the previous character, we say that the previous character is a letter. Okay. Almost there. I'll change this to a for loop and it will work. So previous will start from 1 and previous will be input at 0. Right. And basically we have a letter, and if letter is not previous, it means that it's an end, that we have a different combo. So I do need to have a is start thingy. Which is true. If letter is not equal to previous, if letter is not equal to previous, we set it to previous and say that is start is the opposite. That is fine. And if this is not start, then that means the string ended. And that means that we can increment the count. That is, I think, the approach for this specific one. And in the end, we return the count. Let's run the tests. Almost. Expected 3, actual 2. In here. RL. RL. Okay. Let's see why it failed. Come on. Find count, put the breakpoint here. More like here. Okay. Close this. Continue. Debug. Right. We are at index 1 RL, so it found this L, and it says count plus 1. It's good. Then we go again, and then it jumps to next one, which is R. And start is true, so we don't. Oh, we do need to sum it if, yeah, the previous one, it doesn't really matter, you see, if we start a new string. So if it's repeated multiple times, it doesn't really matter, and that's where it's wrong for our case. If letter is not previous, that is fine. But if we start from 0, we need to set something that the previous one is something that doesn't exist. So something invalid, like this one. And same in here. Previous is this one. Private const char non-existing literal will be this. Is start is true, and is start is false now, and index will start from 0. Basically, we can convert this to a for each loop. And basically, since it has decent nested if, I'll invert if, so it's easier to read. If letter is equals to previous, well, we just continue. All we care about is those points where it changes the letter. So previous is letter, is start, inverts, and is start. If it changed, then, well, if it's the end, then we sum it, and we again reset the start, the previous literal, so that the other one is not in the way. So now it should work. We have one more. Expected 2, actual 3. Expected 2, actual 3. That's weird. Expected 2, actual 3. Okay, let's skip it. What was the input? That was the input. Let's put conditional breakpoint and say input equals this one. Okay. And if we debug, it should break at this case. Input. Oh, okay. This one. Okay. Start again. Okay, so it stopped at the input. This one. Let's see. Balance string counts was 3. Let's go back and see how it proceeded, or why it was like it was. So first one will be here on second character. RL, so it stopped at here. Next one will stop at here. Next one stopped at L. Okay, this is actually supposed to be 3. 1, 2, 3, right? And I'm expecting 2. Why am I expecting 2? It's supposed to be 3. Let's check lead code. Why is this 2? R into RL. Oh, it has to contain equal number and not be mirrored. Okay, I see. So I need to add one more check. And I will split this as an edge case. Right. Right. That one is an edge case. That covers a whole different scenario, so I'll make this explicit. Find count given many characters with many chars with this one with mirrored mirrored, and this one will be with mixed. This will make it more difficult though. Again, okay. So we have this, and it can be this and this, LR, or more, yeah, LR, let me double check this one. I see. Slightly different. Okay. So right. Basically, this one, I guess, is the only one that has that issue. Many chars with mixed LR. Okay. So if we have mixed LRs and that are not really mirrored, what happens? Again, I forgot already. Why was that last scenario invalid? Well, since I split it, I can test it separately. What went wrong? Let's see. 1, 2, and the third one. The third one isn't supposed to happen because why? It is at this point now. So the first one is this. The second one is this. And the third one is this. I don't understand why is it still 2. Let's read again. Balanced strings are those who have who have equal quantity of all and R characters. Given a balanced string S, split it in maximum amount of balanced strings. I think this is wrong. 1, 2, 3. This is wrong. To me, this is wrong. Do you guys agree? Is this wrong to you? Maximum amount of splitted balanced strings. Maximum amount. Maximum amount is 1, 2, and 3. If they meant like this is the maximum amount. R, 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 L, L, R, L, L. They take it like this. Oh. So they basically say that it needs to be split. Like you cannot leave leftover characters. That's what it means. All right, I see. 1, 2, 3, 4. Yeah, okay. Okay, sure then. Then it makes sense. And I should rename my test. Find count given many characters with leftover LR returns expected count. Now let's try to solve it properly. Right. I know the answer. I know the answer, guys. Awesome. Basically, the answer is this. You're moving across this one. So basically, this is 1. This is, again, maybe 1. This is 1. And then you're moving across and you say, okay, I'll stop here, but I cannot stop here. But I cannot stop here. Well, I can stop here, but if I take this one, it will be imbalanced anymore. Like, so if I'm going here and I stop there, then we're left with this one, and we're left with this one. It has 3 L's and 1 R, which is not valid. But I'm thinking, because it seems that there is an even amount of R's and L's. 1, 1. Yeah, even. Always even amount. So I either have one more L than R. So my solution is probably going to work if I also check uh, uh, if I also check how many things are left, but maybe not. But I think they missed, and again, a key thing that it does have an even amount of L's and R's. At least it seems so. So, for example, what if you have L, R, R? Can it be split? I don't know. Maybe. I'd say so. Based on the constraints, I'd say yes. But in this case, well, based on the constraints and the requirements, I'd say that our solution can be considered correct. So I won't waste time. Give me a few more minutes to wrap this up and think if we can do anything about it smarter. Because otherwise this one wouldn't work if we cannot base it on previous. No, I cannot think of anything. So again, that's how we understood it initially, and for now it will be good enough. Let's try and do another problem. Whoops. Problems. So that we start from scratch. Let's take this one. Right. How do we do this? First, let's see the name. Chips. Pair of chips. Chips tests, I'll call it. And let's read. Hey, nice to hear, Overlord. There are some chips, and the I chip is at position chips I. You can perform any of the two following types of moves any number of times, sometimes 0 on any chip. Okay. Move the ith chip by 2 or move the ith chip by 1 to the left or right. So I can move for 3. I move for 3 for 0 cost by 2 units to the left, or by paying 1 unit to the left. And there can be 2 or more chips at the current position initially. Return the minimum cost needed to move all chips to the same position. Any position. Okay. Fair enough. So if I have chips 1, 2, 3, and I need to move all to here. Position 3. So this is the position. So second chip will be moved to position 3 with cost 1. Wait, I don't understand the task. Return the minimum cost needed to move all the chips to the same position. Oh, minimum cost to the same position. Minimum cost is to move by 2. So minimum cost is to move either here or there. And moving 3 to 1's position will be 0. And this one will be 1, therefore 1. And there, 2. And you always try to take the middle part. Okay. So the strategy will be to take the middle part if possible. Okay, that's easy, I think. All right. Test. Chips tests. We have chips. So public void find calculate minimum cost, more like find minimum cost for moving all in chips. Move all to the same place. Move all to cheapest place. Given empty array returns 0. There was no cost. So again, the most simple test is to have the skeleton. We start from a skeleton from the input. So first, the test that just tests the most simple case. Our input is an empty array of integers. And we basically say, the cost is a better word. We basically say that chips, and this is the method that takes input, and we say that cost, well, we assert that cost should be 0. And now let's implement the chips. Well, let's go here. chips public static. Now we can just say chips like this. Boom. Our most simple case int. Our most simple case would just be return 0. That's stupid, so I'll just return a check basically. If input is any, length is more than 0, is 0, I mean, return 0, return 0. Var cost 0. Like this. This is our skeleton. Run. Oh, I forgot. Assert equal. Run. It should work. Yes, so the first test is passing. Let's move on to the next one. Move all chips to cheapest place given trivial stuff. I'll take this one. Given free chips, free ints, free numbers, returns 1. Doesn't matter what numbers. Actually, if there is one number, it still returns 0. Given one number, it still returns 0. And that will succeed still. I think now I can make a theory. No, this is fine. This is still a fact. This is quite distinct as well. Move all to cheapest place given 2 numbers. I don't know what 2 numbers will be because there was an example, but if it's 3 numbers, it returns 1. And that's my input. Fact. Inline date. No, not inline date. What am I saying? My input. One, two, three. Basically, I want to move there. First 2 numbers, maybe it will be easier. 2 numbers, it doesn't matter. It takes any position and moves by 1. Not a very good test, so 3 numbers, I'll take 3 numbers instead. 3 numbers, the output is 1, and there is now logic involved. We go back to here. My strategy is to make this easy. And this means that if we have 3 numbers, it moves to the edge, but it takes the middle one. So if we take those, it takes like the middle one, but the edge, so 1 or 3. Takes middle 3, takes, moves to the last to the first or last of 3. So we need to find the middle. Divide from 2. That's the middle. Let's say the middle was 3, so it would be at 2. That is good. Let's try to write 3, 2, 1, 3, 1, 2, 1, 2, 3. So we have 5 elements. I divide from 2. It goes there. It goes there. If I divide 5 from 2, the answer is 2. If I divide 3 from 2, the answer is 1. Which is good. That's what I want. So instead of middle, because it's not really middle, I'll call it target. Target index. That's the target index. That's where we're trying to move. And now I need to calculate how much does it cost to move to this place. And the rule is this: if you can move by 2 places, you move by 2 places. So let's make a few functions. Okay, this is not good. It can be optimal because you will always move by 2 as long as you can, and only if it's uneven number you'll be forced to move by 1. So basically the price that each will move will be the following. Input.length. We say target index, current index, cost. Current index cost is, so let's make a function private static int calculate cost to int index, int index, int target index. Okay, and the price is, cost is target index minus index divided from 2. Sorry, that is not true. It says it moves by 2 units, and if it moves by 2 units it's 0, the price. So I move by 2 units for free. That means that the last step that I take is the actual price that I pay. So it can be always either 0 or 1. Never more than that. And that is the cost. All right, that is the cost. So for I to go to target index and cost, total cost is current index cost. And that will be pretty much it. Let's see if our test works. Okay, it passes. Now let's add the last things, which is yes, it is 1217 play with chips. Right, and lastly, let's add the test input. If we have 1, 2, 3, we already have that. If we have this one, we expect it to be well, okay. It's not different than the other one, so I'll just make it a given. Okay, yeah, it's not different. It doesn't change anything. So I'll just make this a theory and add the cases. Oh, it needs to be array. Okay. Private, sorry, public, static, enumerable, object, array, expected, chips, output, will be yield, return, new object array, this one. Int array, more like this, and not like that, with expectation. Expectation for that one is 2. Not needed, that's fine. Confusion. Okay. Okay, okay. Not needed. New object array. Okay. Good. TD, great. Great. And the other one was this one. And the expectation was 1. Let's add one more. One more, meaning which it is let's say like this. what's the expectation? The expectation is, well, it's a minimalistic test, so those two are enough actually. Member data, name of this, given n numbers, returns expected cost. Let's run. Oh, come on. Right, I forgot to put this as an input. So it needs to be int array input, and it needs to be expected output, cost, expected cost. Int expected cost input, expected cost, expected cost, and actual cost. Let's run this. Actual 0, actual 0. Why is it 0? That is not true. Oh, that is true. Never mind. Is it true? Yes, it's true. Okay. Actual was 0. Index target index. Cost plus equals current index cost. Return cost. This is actually not even needed anymore. Come on. Input. Cost was 0. But it returned not 0. What the hell? What am I missing? Cost is 1. Cost is 1. Cost is 0. Oh, it should be abs. See, it's a great way of catching bugs. Still not. Expected 1, actual 2. What's wrong? Right. And this is my bad now, because if it's non-even number, if it's non-even number of elements in array, it should move to the one on the edge, not the one in the middle. And the way it works right now, that it moves to the one to the middle. So I need to make sure that if it's an uneven number, it moves to the one on the edge. And how do I do that? It's quite simple. All I need to do is input length divided from 2. I could do an if statement. Oh, let's do it silly. If it's non-even, if it's even, oh, okay. It's like this. If input.length is not even, target index will be this. Because we want to force it to be on the edge. And let's move this to its own function, because it has now some logic. Whoops. Boom. Okay. And if we run the tests again, does it matter plus plus or minus minus? Because I'm not following. Why is it like this? Doesn't matter. Why was it free? Five again. Target index is free. Or is it supposed to be an edge one and not the middle one? Yeah, it's basically the price is always going to be either 0, 1, or 2, but never 3. And by forcing it to hit the middle was a bad expectation, actually. Yeah. Okay. Back to the draft board. If we take this one, this will move 1, 0, 1, 0. Are we correct by presuming that the first one is always the cheapest one? We are. This is not needed. Overthinking. And now let's refactor it, the final step. Can we do anything? Calculate cost to cost plus equals. All we can do is this. Nothing more that I can see that could be simplified. Let's do one more and that'll be enough for today. Math, min, chips count. I'm not sure it's chips count. Math, min, chips count. Yeah. I'm not sure why the first one is needed though, because divided from 0 doesn't say anything. Let's test it. Math min input count. Oh, okay. Right. It's to me this is a bit probably less readable. Let's format it and see if we like what we see. So you take the minimum of either of the two. Yeah, it probably works. Run, let's see. Success, okay. Now, why does this work? It says count all the even chips, count all non-even chips, and take the one that is less. Oh no, sorry. Count. Count even chips, count non-even chips. I understand the way it reads, but the answer is not the count of them. The answer is either one or two always. So there will be more chips than one or two. Oh no, there won't. Okay, never mind. I'm stupid. Sorry. Sorry, that is stupid. Yes, that is correct. But I think in any case, this one is faster than the other two. And it should be actually um yeah, so if our target index is 0, then it doesn't matter. If this is 0, then we can do this, calculate cost based on index, which is just like this. Yeah, and then it ends up to being what you wrote basically. Yeah. Now you say you would have written like this. Let's see. Input group by min. Um, let's see. You would do it like this. I'm not a huge fan. Preferably like this. You think this is the only correct way? Okay, so you group by by the remainder and you count each. So this group by basically represents those two. And yeah, there is one redundant statement removed. Let's run. Well, of course, it fails if it's empty, but that doesn't matter much. Also, if it fails if it's a... Why do I have same input? Does it fail with 1? Yeah, it does. Okay. Okay. If input length less than 2, return 0. Group by on the same line. Yeah. I agree that it looks like that. Neater. Okay. Let's do one more and I'll wrap it up. Okay. Bulls and cows. You're playing bulls and cows. Okay. I'll do a slightly different pattern now. I'll just call it bulls and cows and solve. Or bulls and cows problem solve. So bulls and cows problem test. Public static public void something fact. You're playing the following bulls and cows game with your friend. You write down a number and ask your friend to guess what the number is. Each time your friend makes a guess, you provide a hint that indicates how many digits in said guess match your secret number, exactly in both digit and position. Called bulls. And how many digits match the secret number but locate in the wrong position? Called cows. Your friend will use successive guesses and hints to eventually derive the secret number. Okay? Write a function to return a hint according to the secret number and friend's guess. Use A to indicate the bulls and B to indicate the cows. Please note that both secret number and friend's guess may contain duplicate digits. One bull, 3 cows. Secret and guess. So A is bull and 3 is cows. Sorry, A is bull and B is cows. The bull is 8. The cows are 0, 1, and 7. Zero, 1, and 7. Right. Let's read again. You're playing the following bulls and cows games with your friend. You write down the number and ask your friend to guess what the number is. Each time your friend makes a guess, you provide a hint that indicates how many digits in said guess match your secret number exactly in both digit and position. Okay, and how many digits match the secret number but locate the wrong position? Oh, okay, I see. Okay. And the other one, 1A, 1B. Okay, I see. Um, I won't do the bullshit with empty strings because I noticed they don't care. So let's do with bool.